Okay, many ways to do the problem. What I would be looking around for something for easy to do. So I think if you took the first equation and you could easily solve that for y, and that's what I did over here. I took the first equation, solved for y. All right, so how did I do that? I subtracted x squared from both sides, and after doing that, I divide both sides by 4x. The next thing I would do, I'd make a substitution into the second equation. Wherever I saw y, I would put that 13 minus x squared over 4x. And that's all I did over here. So 2x, that's what the y is, 9, y squared, and they get 87. Now here comes the problem that a lot of students have. They see this and say, oh, I wonder how they did that. And they think it was done by magic. It is not done by magic. It takes work. And work takes paper, pencil, and time. And you should be able to verify that that's true over there. How do you do that? I would multiply both sides by the LCD, collect terms, expand, get it equal to 0, yada, yada, yada. The next thing I would try to do, which doesn't look like a bad factorization problem, I'll be honest with you, it really doesn't. I would use a zero product rule and factor it. And if you did that, it's really easy to do. I mean, really easy. I mean, you get 1521 times 1, and certainly get that internal term of 1522. Then what do? I got troubles here, and the troubles are, what's x? Well, the easy one is x equals plus or minus 1. Now, the 1521 is a little more difficult, but, I don't mind using calculators. X squared equals 1521, so that means x equals plus or minus the square root of 1521. And again, I don't mind using calculators, but again, I've been doing a little research, and I noticed that in a lot of countries, they actually demand that students be able to take the square roots of all kinds of bizarre numbers. And we've done that in prior sections where we used, like bizarre techniques to get square roots. I would say make an assumption, and certainly, it's not 40, because 40 would give you 1600. So you could try 39. Let me go through that, what I mean by that. 39 times 39. And what do you get there? Well, 9 times 9, it seems reasonable because you get a 1 in the end, 81. And then you get 9 times 3 is 27, right? 27, 35. Let's see, you get 3 times 9 is 27. 3 times 3 is 9, 10, 11. And let's see what you get over here. Did I make a mistake somewhere? I got to check myself because I know it's the right answer. Let's see, 5, 13, 12. 5. Yeah, I did okay. So 39 is right. All right. Now someone says, I'd rather use a calculator. Please use the calculator. I don't mind. So we got really 4 separate answers now. And this is a problem for me. When there's 4 separate answers, there's more work. All right. So then someone says, what are you going to do now? First of all, I'm going to start to erase the stuff that we just spoke through. All right. We talked through that. Did I put all the work down there for you? No. Did I do all the work problem? Yes. But then you say, why didn't you write the work down in the key? The key would become enormously long. Anyway, a key is provided as a learning process for you. All right, so what do? Well, to get the y, all you have to do is plug it in here. All right, so if you plug in the 1, 13 minus 1 is 12. 12 divided by 4 is 3. If you did the other one, you're going to get minus 3. Relatively simple, by the way. The other one's more complicated, and there's no doubt about it. I don't mind using calculators. I really don't. The bottom line is you should be able to verify these numbers over here. All right, how would you do that? You can use calculator if you like, or longhand arithmetic. What I mean by that, longhand arithmetic would look like this over here. 13 minus 39 squared, and then you get 4 times 39 in the bottom. All right? Now you should realize you're going to get, if you did it once, you don't have to do it twice. They're going to be plus or minus at this point. All right? I'm going to claim I'd like to look at a picture of it. And for one thing, I'd like to learn about what these graphs are starting to look like. All right. Now, granted, later on we'll talk about more detailed graphing these things. And if you study pre-calculus, you're certainly going to study these things in more detail. But anyway, let's take a look. And this is figure 94, right over here. And I see the 4 points of intersection. Again, there's a claim there's 4 points of intersection over here. Now, again, looking at these things, I'm going to say these are conic sections, hyperbola, all right? Did I go through the work to show that? No, but I'm looking at it. I'm saying conic section, hyperbola. They're rotated, by the way. So let's take a look. Oh, by the way, you learn about rotations typically in trigonometry, and that's when you really study conic sections in trigonometry, because you rotate them. All right, let's take a look. Do I see 1, 3? Let's see. I sure do. I'm going to check it off for you. It's right there. I'm looking for easy ones. Do I see -1, -3? I do. Right there. Let's go the other ones. 39 minus 29 thirds. 39 minus 29 thirds. Now, minus 29 thirds, you're roughly looking around -10. Looks good. Did I get the other one? What's the other one I was doing? Minus 39, 29 thirds, and that's right over there. Relatively simple to identify those things. Again, I would strongly recommend you start looking at technology to graph these things. Wells was not able to do this. Of course, this is back in 1904, but nonetheless, they could have done it. It just took too much manpower. And also, it would take up a large number of pages in a textbook, and they weren't willing to do that, by the way. So, what am I going to talk about now? Who I am. I'm Ron Bannon. If you need to reach out to me, my email address is Bannon, B as in boy, the @ symbol, NNON.US. If you have any questions or criticism related to the written document, please let me know, and I'll try to take care of it. I really will. Thank you so much.